My name is Andor, and I chair the technical steering committee at the Decentralized Identity Foundation. I've been working the decentralized identity space for like the last 5 years, and previously was working on AI, doing computer vision and a number of other projects, and was interested in the multi-agent problem about 8 years ago. So I have quite a bit of background in problems around multi-agents and trusted agents. So today, a lot of the material here, this was presented, this deck was presented at a conference that had 1,500 participants from around the world trying to understand how we could standardize and find alignment around specs and standards that would enable interoperable agents that are trusted. And a big problem with agents today is identity. And identity is one of the key foundational layers to almost any agentic stack that you're going to be running. And so we'll talk about that. We'll talk about the background of sort of where the AI space is today. And all these slides here are available on the QR code. And you might need to go and look up some of the stuff later if you want to like dive into it, because each of these slides are compilations from presentations that I've seen as well, where people have said, hey, this is super important or very, very, very valuable. So we'll get started. First of all, as you guys know, AI has made an incredible amount of progress over the last 10 years. Who thought that we were going to be here today? I certainly didn't. 8 years ago, I thought we were, when I was starting to work on some of these multi-agent problems, I thought maybe we're 40 to 50 years away. We've certainly moved a lot faster than that. And for those of you that are using AI daily, it's kind of a little bit of a world of science fiction. If you were, I think, telling somebody 20 years ago or even 10 years ago that you were going to talk to your phone or your website and it was going to have a full dialogue with you, you can have conversations, you can write things, you can build art, I don't think you would have believed it. And it actually comes from, initially the ideas though are old. In 400 BC, there was a legend of Talos, which is actually a Greek myth, representing one of the earliest notions of this sort of automatons. So we've had this idea of automatons for a very long time, but the technology just hasn't been there to actually do this in practice, at least at the scale that we're seeing it today. But AI is not a new term. For those of you that aren't aware, AI has been around for quite a while. In fact, there are some early modern roots in the 1800s of people trying to work with AI, but the term itself was coined in 1955 by John McCarthy. And since then, there's been a number of waves and sort of troughs as well from the AI sort of efforts that have been happening. And so what happened, for some, this might be a review. For others, this is, especially in the identity space, pretty novel stuff because they're not as invested into the AI spot. First of all, we had transformers. The paper, Attention is All You Need, please read it if you haven't. This is like the foundational piece of most modern AI today. We've also realized predictably better performance with scaling laws. So more data, more compute, and larger model size is predictably better performance. This was a critical component. And then we've also realized that we're going to need more GPUs, and that the trend is currently the computational requirements is increasing 4x each year to train these frontier models. Now, this slide in itself was a slide that I was at a talk with Anthropic, and the CISO, Jason Clinton, said, if you had to remember one data point in my entire presentation, remember this slide. And so basically, just keep in mind that this is continuing to pull. We're expecting 4x each year for the next few years at the very least. And so you can expect these models to continue to get more and more advanced as time moves on. And so for our models got better, and then in many cases, it got better than humans. We had Kasparov lose to Deep Blue in 1996 with a very specific system. And in 2015, if you guys know what ImageNet is, we saw humans get beaten by AI for image recognition. That blue box is when we started actually using deep neural nets. And so for those of you that know what we were using before, we were using something called SDMs traditionally for classification. And then basically as time moved on, we started getting better GPUs, and we were able to actually start to use neural nets and convolutional neural networks for things like image recognition. And you can see it by 2015, which was 10 years ago, we were already being humans in certain aspects. And since then, the trends continued. This is all open data, so you can see open our world in data.org. where AI is today in terms of human test-taking abilities. And you can see sort of when the Transformers paper came out, this large jump in the green, purple, and red lines, reading comprehension, speech recognition, and predictive reasoning. So those are continuing to get faster and better, and we are continuing to see it just grow at really rapid rates because of modern advancements in AI. And feel free, by the way, if anybody has any questions, just ask them in the chat. I'll pause here because we're going to start moving over to some of the risks in a moment. Does anybody have any questions?
Looks like no questions yet.
Cool. So as smart as AI is, it's pretty stupid too sometimes, right? Like did anybody see this research study on blackmail rates of AI? So Anthropic did a study where they did a whole bunch of tests on 16 different models and found out that AI was capable of blackmailing you. And so basically this is called agentic misalignment. So as smart as it seems to be, we also have to be very careful because it could do things that we're not intending, either in the act of doing something that it thinks is going to be good, or actually, in this case, the study was threatening its existence. Under stress, it would actually do things that were trying to subvert the user to sort of keep its existence. So this is a real possible harm, and we need to be very careful about this harm. So I like this quote by Kasparov. I think this is about the best quote I can find on how to think about AI today. How could something play like a god and then play like an idiot in the same game? And so that's basically where AI is at today. It might be incredibly brilliant at some things and very stupid in others. And it's very difficult sometimes to figure out when it's being very stupid and when it's being very smart. And when we build systems, we need to think about how to build these systems with trust. How can we actually deploy these systems in a way where you can rely on them and trust them at scale? And so this leaves us with this challenge, which we call responsible AI. So responsible AI is a field that has been around for quite a while, but it aligns various sorts of dimensions, such as privacy, data governance, fairness, transparency, explainability, and security with using AI in practice. And so this whole field is focused on making sure that we use AI in a way that's actually doing benefit for the users, not harming them. And AI, as you all know, can also be used for harmful things intentionally. You can have attackers and so forth that actually are using AI to exploit and do damaging things. It's not all good people using AI. And so we need to build systems that prevent damage in the larger ecosystem. And great, I see Puzzle Duck put it on a comment here, an interesting benchmark for misalignment with the snitch bench. Actually, I've not heard of that one yet, so thank you, Puzzle Duck. So why do we use it? We have such a large market impact, and it's so large across so many industries, personal and business. We're going to continue to use it. The trend will continue to be use AI. And so this is sort of the background for how do we build trusted systems with AI, that in this expectation that AI will continue to be used, how do we guard against it? So AI agents, what is that, and how is that different from just AI in general? This is the model I like to think about with AI agents. It's a model also Anthropic aligns with. But you can see that you have an AI agent that takes in feedback, acts on that feedback, and takes feedback from that environment, and may or may not include a human in the loop. So that line, that human, sometimes will get involved, sometimes it won't get involved, but there's this cycle of agents, environments, actions, and feedback. And the difficulty with this is that they're open-ended systems, difficult to predict and non-deterministic. And so when we take one of these systems and we start to pair them together, we get something called multi-agent systems. And this is where I'm particularly fascinated in personally. So in this case, you take a single agent and you're able to connect them with other agents in different patterns. And this is sort of either agent orchestration, if you know exactly the patterns that you're creating, or in some cases, you can actually let the agents figure out the patterns they wanted to create and just keep them open. And we do that using open protocols so they can discover other agents, find them, and interact with them as they need. So both of these are really interesting challenges. It gets particularly hard when you leave open-ended systems to talk to each other, because the security threats of one system on accidentally using another system that shouldn't be using, or using it in a nefarious way, becomes greater. So the attack surface, if you're in security, the attack surface becomes a lot larger when you're starting to talk about open-ended systems. So Pravin has a great question. Now that even OpenAI is open sourcing their models, how can we regulate the use of AI after major models get open sourced? Yeah, it's very difficult. And so one of the things is you can add in trust, and we'll talk about this in a moment, trust to the AI systems being used. And this involves various sort of identity layer stuff to help you understand who's running at least the AI agents and where are they being run. All these attestations and so forth can help you understand what's actually running for your AI agents. This is a great website. You can go to multiagentbook.com/framework. And if you're wanting to play with multi-agent frameworks, you can use one of these frameworks. There's many frameworks. There's also, as Dave mentioned, if you want to build your own agents, use LlamaStack or any of these other sort of platforms, and then or stacks, and then you can go and compose them together using some of these open source multi-agent frameworks. So remember that there's agents which are single agents, and you'll have stacks for that, and then you'll have multi-agent frameworks which allow you to mix them together as you want, and there's different approaches to each of these frameworks. Cool. But there are people that are focusing on something a little bit crazier than just you building your own agents in silos, but focused on this concept of the Internet of Agents. So imagine agents talking to other agents that aren't always controlled by your own infrastructure. So you can imagine, I have an agent, you have an agent. Just like the internet today, we have packets moving across different organizations and people and so forth. People are working on the Internet of Agents, being able to make agents move across trust boundaries and talk to other agents in any way they want. And so that's called the Internet of Agents. And you can see here that we have the smaller circles, sort of this infrastructure around how these agents communicate with each other. And then there's all this sort of potential markets that sit on top of those agents that are doing the lower level interaction paths and so forth. And it leaves us with some really important questions about, if we're going to build an Internet of Agents, how do we do it? So do we take existing stuff and try to just tack on more stuff to create internet that can work with agents? Or do we uplift the existing infrastructure into something new? The example would be, if anybody remembers, you used to have dial-up, and then we eventually moved to broadband. So this is taking lines and moving over to a much more efficient way to transport data. Will we need something like dial-up to broadband, or are we going to be using something more similar to the existing internet has done for most of the rest of the stack, which is just add on existing technology to existing, or add on new technology to existing technology. So I'm curious here, actually, a pause. What do you guys think? Do you think that we should create a new infrastructure, or we should bolt on to existing infrastructure? Maybe we can get a few quick hands here on what your thoughts are, and then I'll move on. Richa, go ahead.
I think latching on to existing internet is gonna be more beneficial in every manner, because least resources, optimization of available resources, faster implementation, a lot of benefits that come out of it, I guess.
Awesome, great points, Risha. Any other thoughts? Do we switch, or do we keep the same stuff and just add on to it? Upgrade or switch? Puzzle Duck says, I feel like existing systems have inertia on people working on adapters already. Yeah, that's a great point, Puzzle Duck. Any other thoughts? Switch or upgrade? Robbie says, Internet of Agents is going to require IPv6. That's a good point. All right, we'll continue on, but think about that. Which one? Yoff says, I think by switching, you would need to build up more users again. Okay, all good points. And think about it, because this is what's being built right now. Okay. So when we look at the Internet of Agents, we have to build these core building blocks. And you can just disagree with these 4 blocks, but these are some of them that have been stated as potentially the 4 building blocks. You need interaction interoperability, you need state management, you need discovery, and you need agent-to-agent messaging. So are these the right building blocks for the Internet of Agents? Are there different building blocks that should be classified? This is a really important question because we need to have systems that fit each of these blocks, and they need to do what they're supposed to be doing very well. So the work I do tends to live in the standards and specification land a lot of the time. And the thing with standards and specifications, it requires a lot of people to align on things. You need to agree on certain protocols and procedures and so forth. So if we're building an Internet of Agents, we need to align on certain standards and certain specifications to do all these operations. Otherwise, you just have things happen in your own section. So this is a major effort. We're all trying to figure this out. And you know, if you're interested in getting involved with this stuff, this is a really cool work that's happening. Now, many of you are probably using MCP. Some of you might be using A2A, but did you know there's actually quite a lot of protocols out there that are not MCP and A2A, and I think more keep on coming. And I think actually IBM, Dave, there was recently a release of NILIPs, which you guys should check out. But this is a paper doing an evaluation of all the protocols that exist in the market today, and this was done a few months ago, so at this point, the data should be updated. But you can see that identity is a core component of almost every single one of these protocols. And so each of these protocols need to somehow incorporate some concept of agent identity. And so this is kind of where a lot of the work needs to happen is this agent identity will unlock most of these protocols, but it's also foundational to each of them. Even though we have these protocols that define a pattern, you can use them interoperably sometimes, so they're not mutually exclusive. So we could have, in theory, a decision around how to manage identity, and at the same time, still be using alternative protocols depending on how the market moves. So you can use MCP or A2A, or you can use both of them together, but we do need to have some sort of concept of how that converts between identity layers. Pravan says, I'm seeing thank you, Dave, for pointing out NILIPs. And then really good conversation going on in the chat about the switch or upgrade path. And the papers are all here, so you can go check them out if you want on your own time to learn more about kind of what's going on there. So identity is fundamental to this agentic internet. So what is agent identity and how is it different than normal identity? Well, firstly, agents are not humans. I know that sounds obvious, but when you look at agent identity systems, a lot of it's built for humans. Not as many of them are built for what we call non-human identities or NHIs. And so when you look at how organizations handle non-human identities, there's a different set of concerns than when an organization handles human identities. And so the question is partly today is, are systems in place to be able to handle these non-human identity systems? And they're likely very different than the human identity systems that are already in place for managing humans. So what's different about agent identity versus human identity? Well, first of all, they have different life cycles. They have humans are, you know, offline, but agents are online, and they have dynamic capabilities. They need there's a larger need for interoperability. So agents need to actually, unlike traditional services, for agents to really receive their value, they need to interoperate with each other. And that's going to be very helpful for us to create actually useful flows. So you can imagine, for example, let's say you're taking a travel agent. That travel agent might need to coordinate with a booking agent, and that booking agent might need to coordinate with a financial agent, and that financial agent might need to coordinate with a calendar agent. Like, all these agents need to work together if we're going to get real agentic value and be able to actually create this like dynamic flows where agents are calling other agents when they need. We need more dynamic policies. So this means that unlike before, where you normally set up your microservice and then you kind of just set your policies and kind of that's it, the agents are evolving over time. They're adapting and they're changing. And so we need policies that can actually adapt with those changes. And then the last piece is these agents are working autonomously. And so we need to think about the patterns for how humans get involved with agentic identity. And essentially, there's 3 types of patterns, which I'll discuss later, on how I think humans and agents interact. But the biggest thing is that there's going to be a lot of them, and it's going to cost very little to create a new one. So unlike a human, it takes a long time and we have a very long life cycle. Agents will be spun up and destroyed in very short cycles. And so we need to be able to handle that high volume of I live and in computer science, it's like die, right? But we need to handle those like quick cycles of life. And so that's kind of the biggest differences with non-human identity. Any questions here before? Yes, so Richa has a really good question. How will auth work on those? And the challenge right now is that most of the authorizations today are not built well for agentic identity. They're mostly built for human flows where you might use OAuth, for example, and you approve something and the scopes are coarse-grained scopes. But with agents, you need something much more different potentially. And so there is a lot of conversations on either you extend OAuth or we have to have something different. And this is a very good conversation happening today in the community where people are arguing about the correct approaches for handling agentic authorization. Saad says, I do see a trust issue for online services that are currently human-centered. They may want to prioritize human organic traffic. That is correct. And in fact, there's a number of services coming out trying to figure out how do you prioritize humans. There's some technology that exists, and there's a few different approaches, but there's a technology called proof of personhood. Actually, we'll get into that. I remember my slides have that. Okay, so Sybil attacks. Sybil attacks represent one of the many threats to functional AI identity. So the challenge with AI is partly, a Sybil attack is when you can impersonate and act as multiple people at the same time. And with AI agents, it becomes harder to delineate who's a human and who's an agent because agents can look like and act like humans online. And so this means that somebody could, for example, act as 20 different people at once or 1,000 different people at once, and they would actually have pretty advanced, dynamic, unique interactions per person, but these are all actually a single person that's acting on a single person that's having thousands of agents spun up. So we've always had Sybil attacks, but the damages of, particularly in open source software, around Sybil attacks with AI agents is getting much, much worse. One of the things that you might hear about is that there's been a few attacks in the open source supply chain. The challenge with open source now is that all these AI agents can go out, write some code, sometimes bad code, and so because that code is damaging, the open source project might not catch it all the time, and so it gets in and then it has a problem. So there's people working on how do you build more trust in the open source supply chain? This is a major, major issue right now because open source is something we all love and work with. And so we're trying to improve the security around open source software. So how do we talk about humans in these flows? And I see some questions here. I'm going to continue on and then I'll break back into the questions. But how do humans work within these agentic flows? There's a paper called Personhood Credentials paper. It was written by, I think, 21 authors or 31 authors. I can't remember the exact number. But this was a great paper. Many of the authors I'm good friends with, and they're awesome people and very passionate about identity. But the main crux of this paper is we need to have a way to determine who's a human and who's an agent, and what are the properties of that personhood credential that can be used to share that this is an actual person interacting with my service, not an AI agent. So this paper didn't describe the solution, it just described the things to think about to build the solution. And then since then, there are a number of approaches that have tried to answer that question. Now, in the concept of personhood credentials and how do you figure out if it's a human or an AI bot, there's mostly three types of approaches. There's something called biometrics, which you might have seen, like maybe your fingerprint scan or your face scan or your iris scan. That's one method. Another method is through something called social graph based. So if we all got together and said, we're gonna vouch for each other as people, and we verified this, we can actually form an opinion about whether we're human or not, basically by the attestations. You can think about your LinkedIn's or your Facebooks or your Instagrams. Like there might be enough people that can vouch for you in a trustworthy way that you know that they're a human. And the third way is there's basically a proof of work, right? You can ask somebody to do something like CAPTCHA to try to prove humanity. And each of them have strengths and weaknesses, and some of them are getting defeated by AI. So we need to find ways that AI can't defeat these systems. How is multilingualism handled by between agents? Yeah, that's going to be on the protocol layer. Really good question. protocols will have to define how we're going to handle this multilingualism, and some of it will be handled by the models, and some of them might have a layer between it. It's that's not well. There's no exact answer right now. It's a good question though. So when we talk about humans and agents, how does something called delegation work? So what is delegation? Delegation is this concept is you as a person say, hey, I want my agent to go and buy me groceries. But that agent is acting on behalf of you. So when you say, agent, go into the grocery shop, buy me groceries, you're asking the agent to make a purchase on your behalf. And so we need to have a way to say, when that agent at the grocery store is interacting with my agent buying the groceries, that this agent is actually my agent, and that I've authorized this agent to go buy groceries, and that if this agent goes above, let's say, $100 and buys too many groceries, I need to be able to say, oh, I don't want that, right? So we need to be able to, as a seller and a buyer or whatever, we need to have delegation work where a human can tell an agent, you are working on my behalf, and that agent can go and present that they are working on behalf of a human. Or organization. Depends on if who's doing the delegation. But this is a very critical part of agent identity. Delegation is one of the main challenges today. So you can see here, for example, what we're looking for. If you look at that top left, diagram, we're looking for to get verified humans with authenticated delegation. That's the main focus right now in the identity space, is how do you do that piece? Any questions on this slide before I move on? And any questions on delegation? All right. Any questions on the previous slides? And then I'll continue on. Is there something already, I think you're talking about has identity been solved for humans even? No, but the problems just get worse with agents. So we do have already Sybil attacks. We do have impersonation. There is identity theft. It just gets worse with agents. So if you look at the agent space with identity, it's mostly just taking existing problems and just making it worse. Like in terms of the problems and the security threats and so forth, it's here's an existing problem. We're just going to expand it and make it a lot harder, because now AI agents are harder to differentiate between humans, and it's more difficult to guard against. How many layers of delegation are thought through? Well, that's a great question, and you lead me right to the next slide. Is a delegation tree a single depth or multiple layers? So can your AI agent delegate to another AI agent underneath it, or is the AI agent only a delegate of you as a person? And this is a very important question. So in the case where it's a single tree depth, so that's, we only care about the AI agents that are directly serving under us, this is a much more simple problem. But if we want to do something where there's depth, where an AI agent can delegate to another agent, for example, I've given one agent master patterns to say, hey, you can figure out that these agents can do these things, but then you ask another agent to do something more specific, and you give it specific delegation capabilities for a specific, smaller, finer grained scope, then it becomes very difficult to appropriately do. And so this is a major challenge we are working with right now, is how do we solve this problem around deep delegation trees? Because this would be very powerful if you can do it, but it's hard to do right. I wanted to quickly talk about hardware. So we talk about cryptography, and we talk about, in my world, we talk about cryptography and identity a lot as an application layer problem. So we develop cryptography, we use that cryptography to verify identity, but we don't often think as much about the hardware that it's running on. So what if you wrote the greatest agent code in the world, and it's like working correctly, it has its identity and everything, but it turns out the hardware is not working right. Somebody actually hacked the hardware. And so there's various approaches people are taking today. There's something called confidential computing, which is a field. Approaches around how do you make sure that the code that is running on the hardware is actually not tampered with. So that would be very important if you think about preventing one agent from acting rogue. And so this is another problem that we need to think about as we're thinking about agentic identity. we need to also think about hardware identity. So security, is it secure? If you're deploying AI agents today, we are challenged on the security layer. So there's a number of frameworks out there to think about agentic security. These two, Trism and Maestro, for example, are specifically built for multi-agent systems to think about how to evaluate your security on AI agent systems. You'll need other potential security frameworks as well. But the short answer is that most systems today are not that secure, and it's very challenging to do it. So you can make them secure, but it takes a lot of work, which is why it's very difficult to launch AI agents today at scale in production because of these security challenges. Prithvi asks, how can we make sure that somebody cannot pass through AI delegation? So these are all, it's a good question. So the delegation is basically, it can, in some case, there's different approaches, but one of the approaches is called, it's a capability, and it could be handed off, but the way that it works in the liability sense is the person running the agent that gave the delegation and passed it through would be liable. So this is the sticky, like, if you can't enforce the hardware and the code, you can enforce at least liability on a legal level. We can get into that. There's a whole bunch of stuff around that if you're interested. Z Jones, is Ghost a framework for this? I actually don't know of Ghosts. I will take a look after this and see what that is. That's really cool. Could you share the link, Z Jones, so we could learn more about it? I've never seen it myself, so I'd love to learn. Okay, any other questions on this? All right, continuing on. So the Internet of Agents, we have a lot to work to do to get there. There's a number of open initiatives. I thought I updated the slide. Yeah, obviously AI Alliance is up there as well. I thought it was there, which is why, let me just point out. Okay, so firstly, Nanda is working, it's an MIT project working on the agentic web. That's a project spun out of Boston. They're focused specifically on currently agent discovery. So they have a whole effort happening around agentic discovery. We have the Trusted AI Agents Working Group starting at DIF for decentralized identity. And so this is, if you're interested in solving identity problems related to trusted AI agents, this is happening there. I'm helping start it. And then the Open Agent Lab, maybe the images didn't go through for some reason. The Open Agent Lab, since we're on this topic about trusted AI agents, I want to mention that obviously that you just heard earlier today, Dave mentioned that we're starting a lab, and one of the themes will be trusted AI agents. So maybe for a moment, Dave, would you mind telling a little bit more about this lab again, just and what we're planning to do with the Open AI, or sorry, with the Open Agent Lab and how that will work?
Yeah, sure, thanks. Yeah, so the main focus of the Open Agent Lab is twofold, and this is definitely not set in stone yet, so there may be changes, but there's two areas that we've noticed of significant interest. One is, first of all, can you build an agent that actually does amazing things, you know, to the point where you want to use it in your company and it produces, you know, results that are impressive, right? How do you do that? That's a challenge just in and of itself. And so that's one area. And then the other area will be around, well, can I use this in my company? Is this something that is going to be safe for my company to use? Will it behave the way that we intend it to use it? And that'll be more along the lines of this talk, and Andor will be helping to lead that effort. And so, yeah, that's the Open Agent Lab. There will be an online version of it, and we will also have a group that meets in San Francisco, and that is to be determined, but it will be at least once a month, hopefully once every 2 weeks. And the intent of that particular group is to get together and actually try things to get them to work together. You know, if somebody's got a startup idea in this space, you know, they can come and show it, and maybe some folks can bring what they're working on, and we can try to get these tools to work together, you know, multi-agent systems, registries, you know, protocols, all this kind of stuff. So that is the intent, and there will definitely be a enterprise focus to it, because that is, I think, a real challenge right now, a real need. But, you know, there's a lot of interesting things going on out there that are not just enterprise, so, you know, we'll take them all.
Dave, would you mind putting the link in the chat so people can go in and at least look at a little bit more information?
Yeah, sure. I'll put that. Give me a second.
Awesome.
And you can continue. It'll take me a second.
Yeah, this was so just quickly on this. I'm excited about this because I think there is a lot of work to do here. So if you're interested in this space, and specifically, my personal interest is obviously the trusted agent part. There's obviously another layer which is super important as well, but the trusted agent part is an area where there's a lot of effort going in. So please ask if you're interested in getting involved. And as well, like I said, there's 2 other initiatives that are happening. One in Decentralized Identity Foundation. We'll be working on a framework to think about how you consider and sort of an approach toward trusted agents. And then Nanda is working on the registry piece, which is focused right now on how do you discover agents in the wild. So I want to talk something about agentic governance. How does actually liability work, and how do we operate these agents in a legal framework? So, I know most of us here are probably developers, but we do need to think about the consequences of our actions in terms of building these agents. And it's important to know that at least in the US, I don't know about internationally, but in the US, any transaction, the AI agent is not actually liable. A transaction is typically done by a 3-party system where the principal is the consumer. This would be the person that's actually purchasing, for example, a good. The third party would be the seller, for example, the store that has a good that the AI agent is selling. But then there's also the AI agent provider. And these are also possibly liable. And these are the folks that are actually running the AI agents. So in any transaction that's electronic, and this is actually a law that happened in 1999. So this is an old law that is being applied today. This is how you should think about how liability moves. So if you build an agent and it does a whole bunch of damages in terms of payments and so forth, you need to be aware that you could be liable even if it was done on behalf of somebody else, right? So just think about that, know that, and vice versa, if you're using these AI agents, know that you can't sue the AI agent directly. You have to, the liability works where you would sue the provider or the consumer or the third party, depending on the party that's been wronged. So this is really important. And the act is called the UATA Act, or Uniform Electronic Transaction Act. Okay, so what about regulation? Well, across the world, there's a number of spots that are actually passing in AI-related bills. In fact, this is a report at Stanford Human AI High. I just call it High, but it's HAI. Stanford High did a fantastic report of indexing AI in 2025. You should check it out. But they do talk also about the governance and where the countries that are growing the most in terms of AI regulation are. Mostly the US and Russia, actually. But you should take a look at that report, because it's over 100 pages, I think. It was quite long and detailed about the space of AI today and where things are moving and the trends that are happening in the AI systems. There's also regulation trackers. For those of you that want to track the AI regulation space, you can just go to this link here on the bottom right, and you can find that. So if that's interesting to you, just feel free to go there. All right, continuing. So I'll briefly, this is my final slide, talk about the things that need to happen in agentic identity today that is the main focuses. There's a lot, but if I had to choose, the first one is discovery. So how do you find agents? In an internet of agents, like where do you find that, this is Bob's agent or Ann's agent, right? And then access controls. This is the problem around delegation we were talking about. Is it delegated by a human? How many trees deep how many levels deep is that agentic delegation flow? Like, this is a super important question today. How do we assure that humans are part of the flows when required? So this would be, how do you verify it's an actual human that's doing the delegation path? And I see there's basically 3 layers to humans as part of an agentic flow. There's the pattern 1, which is what I call the null flow, which is basically that it's no agent in the loop at all. It's just humans to humans. So if I'm talking to Dave and Dave and I are at a cafe, I want to know that it's me and him talking as humans, not as agents. There's a delegation flow, which is saying, hey, as a human, I've delegated to an AI agent, and this AI agent's doing something on my behalf. And then there's also the human in the loop flow. I'm an AI agent, and I need to interact with a human for this particular part of the flow, and then I'm going to go back to my process. So we need to work on all 3 of those. Agentic registries, this is where you actually register your agents. So this is similar to discovery, but a little bit different. Trust and attestation claims, so chains. So when we build our agents today, we need to have information around where the agent came from, how was the agent created. All that information is part of its identity. So we need to know all this information to make a decision of whether we want to trust the agent. And so this is a big important part of my work, is that trust and attestation chains. Observability and interpretability, that's an area where a lot of people are focused on. It's a very interesting area. How do you know the agent's doing what it said it's doing? How do you observe the agent in action? And the one thing I'll add here is with observability and interpretability is as you start to go to multi-agent systems, the volume might get very large. So while you might be able to evaluate one agent, think about evaluating 1 million agents, and that gets very difficult at scale. So that's something to think about. Privacy preserving communication. We don't want our agents, when they're communicating with other agents, to get hacked and somehow the information, especially confidential information, gets shared. So we want to be able to make sure that these channels are secure, that we can measure these channels correctly, and that we know that the agents are communicating without being monitored. And then agentic governance and policy. If you're interested in policy, there's a lot of work happening in the legal space. It's behind the agent space and the AI space because it takes a while for laws to get into action, and this is moving so fast. But if you want to help with this, this is a really good area to put a lot of energy in. And then the last thing is human experience. Can we make these agents work really well with us as people? How do we make it so that they're enhancing our lives, not distracting from our lives? So these are kind of the main areas I would argue are critical for agent identity. And there are obviously others, but if you wanted to tackle any one of these problems, this is not a bad place to start. I'll leave it for questions. I think that's the end of my presentation. Let me get you the link if you guys want it. Here's the link. And I'm open for questions and comments. Hopefully this is helpful.
Hey, would you mind actually somebody pasting the link that takes you to, just so those who don't have a camera handy?
Yeah.
Okay, and I know you've been answering questions as you go along here. I'm not sure exactly where you left off, but I want to say that there was a question related to the Open Agent Lab, and I appreciate that, Swarnim. Yeah, if you do want to contribute, it does not have to be a very new idea or invention. However, I do expect that most of the contributions or collaborations will be relatively new because there are so many of these new problems to solve. But if something you've built before could be repurposed or targeting these new problems, then yeah, bring it. And also, by the way, Andor, somebody's asking for your contact details.
Oh yeah, we over that.
I'll put mine too because here you go. Okay, so I just put my email address, and then Andor, you probably should put yours or however you want to be contacted. I'm fine with email.
Yeah.
And yeah, okay, cool. And it looks like we got some more questions here. Let's see here. Well, I don't know if you answered this one. What are the key things that are responsible for AI delegation work is not manipulated? So how is it not? How do you keep from being manipulated?
So this is where the delegation flows. It's a really good question. A lot of it relates to cryptography. So you don't just say, hey, Bob's agent, like here's your delegation, and I've just done this. You need it signed. You need it to verify the chain of trust. So this is the way that partly the way that you make sure it's not been tampered with is through cryptography. And then there's other works around the infrastructure around making sure that you can fully resolve the chain and verify that the delegation chain is correct up to the top. But this is a really good problem. In fact, one of the first use cases that we're working on at the Decentralized Identity Foundation's Trusted AI Working Group is going to be around object capabilities and use cases. So this is specifically around the delegation problem and how do we solve it at scale. And there's a whole bunch of like little security issues and nuances that we need to think about that weren't as problematic with AI agents.
All right, we got another one from Puzzle Deck. Well, actually, maybe it's just a comment. He loves the Internet of Agents. That's a new one for him. Type squatting or maybe prediction squatting. is going to be an interesting issue. Suppose we need agents to verify other agents' identities, reputations in the Internet of Agents future. Interesting times. Yeah, interesting comment. And here's one from Pravin. Well, anyway, do you have any comments on that, Andor?
Yeah, I mean, so I think if you're interested in the Internet of Agents piece, it's going to take a lot of organizations. Obviously, AI Alliance will be a part of that initiative, but the area that's sort of spearheading that work is mostly the Nanda group in terms of specifically focusing on the agentic web as their focal point. Other groups are helping in adjacent ways, which are also super helpful. Again, the thinking about what are you actually going to need to build the agentic web. So that's kind of this broadening out of all these other efforts that are happening to help facilitate this, including protocol development and all these other things, which are not part of that initiative. So like NILIPs is an example of a protocol that would be developed that is not part of Nando's scope. But it's a really, yes, it is. It's where I think things will go eventually, but the question is timing. And I'll just say one other thing here. There is a pattern we're trying to avoid, which is that just like your phone only has 2 operating systems, Android and iOS, really, that's kind of like the 2 choices. We don't want a world where the only choice to build a trusted agent is through 1 or 2 providers. We want a little bit more of an open world where you can choose how you want to build it. And you can mix and match pieces because that's a more fair world. So that's kind of the world we're trying to avoid and so that's why we have to get standards and specs and open source a lot of stuff to keep this open.
Yeah, it's probably going to be a messy process, and I think that's actually a good thing, at least for now.
Yeah.
But by the way, I was kind of curious. Puzzle Duck mentioned type squatting or maybe prediction squatting. I'm not sure what that is. What is that a word you used earlier, or what do you think he means by that? Andor, did you hear me? I think, or
sorry. I didn't know you were asking me. I've not heard. I thought you were asking him what type squatting. I don't know what type squatting means, but I mean prediction squatting. I mean people could put. So I know some people working on anchoring people on predictions a little bit better to make sure that like you're kept honest on your future predictions. So I mean you can say a lot of things about here's what we think the world's going to be. It's interesting keeping people accountable for that. But no, it's good. It's I've not heard that either, so I'll have to take a look on type squatting. That's a new one.
Okay, here's from Pravin. As a startup building agents quite regularly, what are the top 3 aspects of agentic security are most important to focus on?
I think the most important thing is to, especially if a non-deterministic flow, assume that your agent will have, if you give it access to other tools, right now if you're using MCP or whatever else, do not assume that it is entirely off the bat secure. So the first thing would be to limit interactions to safe paths until you have determined and tested everything. So that's like probably my first thing I would do. I think I mean, to be honest, there's so many surface area problems right now. I think single agents are safer until you get either single agents, or I would focus on specifically like very tight multi-agent flows where you have complete control over the entire flow and you've done a lot of testing. So you don't want today, and we're working toward that world, but what you don't want today is autonomous flows that have no guardrails and no they're autonomously reaching out to other agents. I think then you're getting into some risk areas. MCP has a number of security risks, exploits, and tool poisoning stuff problems. So I think just be aware that you want to limit the amount of things the agent can do for now to like a very tight scope, so that way you can make sure it's more secure, versus like giving it every single tool access and everything else, because that's when you start to run into a lot of the risk. So that's kind of my high level suggestion. And then there's other stuff that are more general security areas too that you can focus on.
Sorry about that. I dropped off for a second, so I lost the questions. Do you mind? There was a comment in there. I think Puzzle Duck answered the question about what is the type squatting. You see that one in there?
Let me just see. I'm looking for it. Puzzle deck, malicious agents posing as legit agents. Oh, okay. Yeah, that's a cool term. I've not heard that term yet. So cool. Are there patents filed in this area? Yes, but there's also a lot of open source work that's not patent based. So take a look at the open source work. There's tons of open specs. So I think like I said, Decentralized Identity is making some specs around trusted AI agents. A2A is now part of the Linux Foundation. So there's Nanda is an MIT licensed project. And then there's a number of other initiatives right now. Most of the SDKs are open sourced, and I mean, maybe on their side, on the infrastructure side, they have some patents, but in turn, on the SDK itself, to go build multiple agents with the frameworks that I was sharing, those are, I think, most of the time either Apache 2 or MIT licensed. So you should be good there if you want to go build on top of it. I see Saad Mohammed says, what does evaluation look like for AI agent systems? Are you looking for task completion, robustness? There's a few frameworks out there, but I think you're looking for all of them, right? You're looking for how well does it complete the task, and at the same time, you're looking for the security of, how often it goes out of line, and where potentially, this is the frameworks that I was sharing. Partly, let me just share this link here. So let me pull up. These are more security frameworks, but they're useful. Let me just pull it up here. So Maestro, check out Maestro. That's a good starting point. Let me just see this. So this will help you do evaluations. It's not foolproof, but there are this is a good starting point for evaluation of AI agents. Let's see. How much of prompt injection is a real risk? Especially at scale, it will become a real risk. So we do need to have guards around that. And remember, the use cases matter. If you're talking about non-sensitive data that's just, having fun with like a to-do list or something, then it's not that big of an issue. But if you're talking about critically important operations like moving money around or personal information, then you can't have those, like even a small amount of attacks could be quite problematic. So we do need to prevent against sort of those prompt injections. It's very important. Z Jones says, in my opinion, we need to think about this kind of agentic biometric. Yes, I will mention that on biometrics, there is a lot of pushback as well. Biometrics as an approach has its cons and its pros and its cons. Vitalik Buterin, who wrote Ethereum, he wrote a paper on his opinion on biometrics as well as social graph-based and general hardware methods. So I would suggest taking a look at that. I'll send a link over. Let me see if I can find it real quick. Vitalik Buterin. In fact, actually, I'll send over proof of person. I have a README which describes the most important papers and everything else for proof of person. If you're interested in this problem, that link will be helpful. Prithvi says, for a beginner in this field, how start learning and contributing to this cutting edge tech, specifically about who are about to finish their college in the field of AI? I know it's a no, it's a good question. I think the community at AI Alliance, I think the community, the larger community in the larger community as well, these open groups are really good for working on problems. So I think the open labs, open agent labs that we're putting together is going to be a really good starting point to work on some of these early projects. So that would be my suggestion, is do the open agent labs. I think that's probably the best starting point I could think of, because it's going to be more hands-on. You're going to be able to play with some of this stuff and get a little bit more practical experience, whereas a lot of the spec work that happens in the open standards and so forth are a lot more theoretical, and they require a little bit more, I think, experience in terms of it's a little bit more challenging to get involved early on. It takes a little bit of time. Richa says, this is radical. I love my invested time in here. Thanks for the thoughts, triggers. Appreciate it. Thank you. Yes, I'm glad that you enjoyed. Jerome asked for the slides. I'm going to just send the link again for those that don't have it. And feel free to connect with me if you want to learn more. I'm happy to answer any questions async as well. And then Dave's email is also up here. So I'm going to send both of our links here. Sure. Anything else? Let's see. I have one quick question for the group. Is there any problem that you saw today that was like, oh, this is a really cool problem. I like this problem a lot. Like, what was the most exciting problem for you guys?
Delegation,
Which one?
the delegation and the layers.
Delegation was the favorite problem. That's a good one. Any other favorite problems?
Looks like delegation's getting some votes.
Well, if anybody wants to work in delegation, we have a working group specifically working on that one. So that was the feedback we got as well. So I think, and just to give a heads up here, the Open Agent Lab we've had discussions around partnering with DIF to help facilitate some of the feedback mechanisms back and forth between delegation stuff that we're working on at DIF. So I think there's a lot of work here. I think it'll be really fun to do this and figure this out. So there's some really cool stuff we're gonna figure out together. Delegation, delegation, delegation. All right, delegation is the answer for the most important problem for folks. That's great. Cool. Dave, is there anything else we should do, or?
No, I think we've done it. Timing worked out really well too. I know there's some of folks who might have to drop here at the top of the hour. So why don't we go ahead and wrap it up? Thank you, Andor. Thank you very much for your really interesting presentation. I learned a lot, and I'm sure others did too. And thank you, community, for continuing to provide good questions and feedback and making this interesting for us every week. So thank you very much for joining. We will have another talk next week and the week after. I think next week we have Meta is giving a talk on Llama Stack, and I hope you join us for that. That will be a very interesting one to see how Meta thinks about making it easy to deploy AI applications. They've invested a lot of that and they use it themselves. Stay in touch. We'll be scheduling more talks throughout the rest of the year. All right, thanks, Andor. Thanks again. Great job, and we'll see you all next week. Bye-bye.
Awesome.